Okay, so it looks like we've got the live stream and everything ready. So we'll just go ahead and wait until 12:55, and then we'll go ahead and get started then. Yeah, so King asked what should we talk about for this discussion. So we're going to be going over some practice problems on the discussion slides. So if you actually go to, if you want to see what those problems are going to be, you can go to modules, and under week 1, you should see discussion 1. And then there's this pre-lecture slides, and you can download those if you want to see the other problems on your tablet. And that's kind of what we'll be going over for the discussion. And we'll just go ahead and wait another minute just as people start to keep rolling in, and then we'll get started. Yeah, everything is looks good. Everything's streaming correctly, and we're live on YouTube. She asked, are Thursday sessions handled by TAs? Yes. Yeah, so it's, I'm the lead TA for this session, so I'll be kind of going over the problems. And then the other TA that's in here is Mark, and he's going to be looking at who's raising their hands and reading chat questions and kind of taking over the questioning portion. So just a couple of reminders before we jump into the discussion, some of the practice problems. So just like with other Zoom sessions, just make sure you're muted. And then if you want to ask questions during the discussion, So you can do that either two ways. You could use the raise hand feature and then Mark, the other TA here, he's going to keep an eye on that. And then he'll just call on you or ask you to unmute yourself. And then the other way is you could just post your question in the chat, and then Mark will relay some of those chat messages up to me. And then the other reminder just for discussion sections, make sure being an active participant. So we're going to be doing lots of example problems. So make sure that you're working them out yourself, so that way you can ask questions, you know how to do these problems, because these are similar problems you're going to be seeing in the pre-lecture quizzes, on the homeworks, and stuff like that. So we can go ahead to the first problem. Then, so here's our first discussion problem. So we've got this sequence here, and we've got this recursive formula. So we've got the sequence starting at A1 equal to A, and then we have either A sub n is A sub n divided by 2b if n is even, or A sub n is A sub n minus 1 divided by 2 if n is odd. So we kind of have these two cases depending on if n is even or if n is odd. And so as an example, you can see here, right, if we were going to do A2, then we just follow the even case because 2 is even. So that's A of 2 divided by 2b, just following the case. So that's A1b, and A1 is A, so that's AB. And then the other example they give is A5. So for A5, 5 is odd, so you go to the odd case. So we've got A sub 5 minus 1 divided by 2. A, and that's just A2 of A. And we just solved A2, which is AB, so that's ABA. So that's kind of how the sequence works. So for the first part, if you just want to go ahead, take a minute or so by yourself and work on just this part A. So writing down the first 10 strings in the sequence. And then if you have any questions on this, you can go ahead and put them in chat or raise your hand. Okay, so she asked a question. What does the first 10 strings in this sequence mean? Yeah, so that means we're going to find what the value of A1 is, the value of A2, A3, A4, all the way up to what A10 is. So basically just going to find, yeah, those are kind of the first 10 strings in the sequence, just because we're defining like AB and ABA are just strings. Okay, so let's go ahead and, does anybody need any more time on part A, finding these 10 strings? Yes? Okay. Wait just a little bit more. Okay, so it looks like some people are done. So we'll go ahead and discuss it. It's okay if you're not. That's fine. So let's go over this part A. So we already had A sub 1 we were given was A. We just solved A2 on the other slide, which is AB. And then does someone want to volunteer to give me what they got for A3, A4, and then A5 we solved on the other slide, and that was ABA? So someone want to raise their hand or put in chat what they had for A3 and A4? Okay, looks like Jackson, you can go ahead.
Okay, I had ABA and ABB.
So for 3, you had ABA,
Mm-hmm.
and 4, you had ABB.
Yes.
Okay. How did you get 3?
So for 3, since the formula is you subtract 1 and divide by 2, and so 3 minus 1. 3 minus 1 is 2 divided by 2 is 1. So I guess maybe I'm wrong and it would just be AB. Or no, BA?
Close.
Actually.
It'd be AA.
AA.
Yeah, because we've got A3 is equal to, we
Yeah,
go to
I
the odd
see.
case.
I see.
And
I
then
have to. I see what I did wrong because I have ABA somewhere else later. So
yeah, that's fine. Yeah. But good. Yeah, lots of good answers in the chat there. And then we've got the other ones. We've got A6, A7, A8, A9, and A10. And then in the chat, or by raising your hand, does anybody else want to volunteer for the other 5? So looks like 7, you can go. And you can tell me if I... Yeah, tell me if I mispronounced your name.
Savine.
Savine?
Okay. Yeah. So A6 I got AAB. A7 I got AAA. A8 I got ABBB. A9 I got ABBA. And A10 I got ABAB.
Yeah, perfect. And it looks like, yeah, lots of, yeah, Brendan, that looks almost right in the chat. Yeah. So that looks good. Does anybody have any questions on any of the rest of these? It's mostly just plugging in the formula and just kind of working it out. But are there any questions on how we got any of those? Cool. Doesn't look like it. So we'll go ahead and move on to part B. So for part B, we want to use those results that we just made, and we want to try to find what A17 are and then A21. So go ahead and take a minute on your own and work out those. Yeah, so Jackson asked if you could see the slide one last time. Yeah, I can go back just for a second. I'll also post the scribbles of all these online after the discussion is done. Okay, so I'll go back to the B then. Okay, that looks like most of the people in our video are done. And so, yeah, we've got some answers in the chat, it looks like. So for A17, they said A, B, 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 A. And then for 21, they did A, B, A, B, A. And it looks like everybody agrees with that. And yeah, those are the right answers. Just to show you for one of them, I'll go over, so like A21, we just follow the odd case. 21's odd. So that's A21 minus 1 divided by 2, A. 21 minus 1 is 20, and 20 divided by 2 is 10. So we've got A10, A. And then if we remember from the last slide, A10 was A, B, A, B. Let me just finish off with the A. And then that's how we can get A21. And then similarly for A17. Okay, so Cameron, do you want to ask your question on what part is confusing you? Or you can raise your hand or just unmute yourself.
Yeah, I just wasn't understanding where the B's come from when you're plugging in the just when you're plugging in the in value.
Where the B's come from?
Mm-hmm.
Yeah, so
if it's odd, if n is odd, I don't understand where you get a B from that formula.
okay, yeah. So if n is odd, you are right. We're gonna take whatever a sub n minus 1 divided by 2 is, and then we're gonna add an a. But we can get a b if this value contained a b. So like in the A21 example, we end up with A10 and then A. And if you remember how we found A10, that one had B's in it.
Mm-hmm.
And we know it'll have B's in it because it was even. So we know it had to end in a B. But yeah, so that's kind of how the...
So how do we know that that's AB, since we plug in a 10 and then that's A5B?
Yeah, so we can solve it for 10 here. So we've got A10, and we go to the even case, and that's A5/2. Or
10/2.
10/2. Yep. Did the math in my head as soon as I wrote it down. And then that's A5B. And then so now we go to whatever A5 is.
Oh, okay.
And 5, we had AB, A. So that's AB, AB. So just because this is like a recursive formula, so we need to know all the previous values before we can know the later values.
Okay.
And then that's kind of where the B's come up. Yeah, good question. Any others? No, looks good. Okay. And then, so we'll go to the last problem here. So here we suppose that we already know what A315 is, and then we're asked to find what A630 and A631 are. So if you just want to take a minute or two on your own and kind of work through that. Okay, so it looks like we've got a lot of people are done. We got Xavier put an answer. So yeah, A, B, B, A, B, A, B. And then for 631, he said A, B, B, A, B, A. And that would be correct. It looks like a lot of people in chat agree with that. Yeah, so I can just show you, we'll just go through one of these. So we could do A631. So we go to the odd case because 631 is odd. Then you got A631 minus 1 over 2A. And that's going to be 630 divided by 2, which is A315. And then we were given what A315 is, so we just add an A to the end of it. And then that's how we get A631, and then similarly for A630. So any questions on this problem for how we got either of those two answers? No, looks like we got it. So let's go ahead to the second problem. So here we've got a problem on some closed and recursive formulas. So here we've got the sequence 3, 6, 9, 12, 15. And then we're going to determine the next number in the sequence. So just in chat, if you want to type what the next number would be in the sequence. Yeah, lots of right people in the chat. So 18. That's how we would get the next number in the sequence. And so if you just want to, we could obviously see, just adding 3 each time, 3, 6, 9, 12, 15, 18, etc. So if you just want to spend a little bit of time going over how would we give a closed formula for this sequence? Yeah, so lots of good responses in chat. So looks like the consensus is A sub n would be 3 times n. And that would be correct. The way we can kind of see that is, so we've got the sequence 3, 6, 9, 12, 15. And then this is the first value in the sequence. This is the second value, the third, the fourth, and fifth. And then we're going to see that they're each just 3 times whatever those numbers are. And yeah, that would be the closed form for this sequence. Any questions on the closed form or how we would come up with that for this one? No, looks good. So yeah, if you want to go ahead and just spend a little bit of time on coming up with the recursive formula for this one. Yeah, lots of really good answers in chat there. Yeah. So for the recursive formula, we would have a sub 1 is 3, and then an is an minus 1 plus 3. The important thing is, remember when we're doing the recursive formulas, we really need the starting condition. So it's really crucial that we have what a sub 1 is. If we don't know what the starting value is, and we just give a sub n is a sub n minus 1 plus 3 is the answer, you're never going to be able to actually figure out what any value is, because you're always going to be looking for what a sub n minus 1 is. So we kind of need that stopping condition whenever we have these recursive formulas. So make sure you put that a sub 1 is 3. One thing I want to go over, so it'd be kind of easy to find the recursive formula in this one, just because they're each going up by 3. So we can just see that it's just whatever the previous number is plus 3. But one way we could kind of find this in general, one way, yeah, and Jackson, if you want, when people are typing answers, if you're taking a little bit longer, you can just close the chat window. I don't think they pop up automatically on your screen. Just if you want to wait. Oh, they do. They automatically pop up. Oh, okay. Then yeah, we'll have people wait the next time around. Thanks for letting me know on that. But yeah, so I want to go over just kind of how you'd find the recursive formula in general for this, because on like a harder problem. So one way we could do it is we find the closed form first, and then we can solve for what the recursive form is. And this is a little bit more systematic way. So what we can do is we solve the closed form, and we got a sub n is 3n. And then because we want to find the recursive form, we want to relate this to the previous value. So we know that a sub n minus 1 would be 3 times n minus 1. Because remember, n is just a variable, so we can just plug in n minus 1 for that value. And then if we expand this a little bit more, we get a sub n minus 1 is 3 times n minus 3. But what we notice here is we know what 3 times n is equal to. We have it right here. 3 times n is just whatever a sub n was. So we can plug in a sub n for 3n here. And we get a sub n minus 1 is a sub n minus 3. And this is just plugging in that the closed form, a sub n is equal to 3n. And then if we solve for a sub n, we get a sub n is equal to a sub n minus 1 plus 3, which is what you all had for the recursive formula. But this just might be a little bit more systematic way. If you're on like a little more difficult problem and you're having a little bit harder time trying to find that recursive formula, you can do something like this. So are there any questions over this? Can you do that so Lance asks, can you do that the other way to find the closed formula? If you're given the recursive formula, can you find the closed formula? Yeah, so sometimes you can. It depends. Trigger sequence is a little bit harder to recognize the closed form. Closed forms are often times can be much more difficult than what the recursive ones are. So like if you read the book, it talks about like the Fibonacci sequence. And so the Fibonacci sequence is a really easy recursive formula. For the Fibonacci sequence, we've got the first value is 1, f2 is 1, and then f of n is just the sum of the previous two. So fn minus 1 plus fn minus 2. So this has a really simple recursive formula, but the closed form of this is extremely complicated with lots of square roots. And it's quite a complicated closed form. So yes, you can, but it's oftentimes going to be a little bit more difficult sometimes to go from the recursive one. What you want to do for the closed form is often just look for patterns. So one way we could think about this sequence, 3, 6, 9, 12, is we just notice they're going up by the same amount. And if we remember from calc class, you'll probably remember that this is called like a arithmetic sequence. And arithmetic sequences are just ones that go up by a constant value each time. And then there's geometric sequences that don't. And then those kind of give a little bit, knowing what kind of sequence it is often leads to an easier way to find the closed form rather than starting with the recursive form. But yeah, going this way, starting with the closed form and going to the recursive is a pretty easy process. Any other questions on closed or recursive formulas? No, looks like you're all good on the closed recursive formulas. cool. So we'll go ahead with the next problem. And so this one's going to give us a logic problem. So here we've kind of got 3 people here. We've got A, B, C. And then we're going to let these variables P, Q, and R represent the statements that either A is truthful, B is truthful, or C is truthful. And then we want to write down basically symbolic logic for all of these sentences below. So we're going to try to convert these into our symbolic logic notation. So using our ands, our and symbols, our or symbols, negations, et cetera, into logic. So if you want to just take a minute and try to do A of the first problem, and then we'll wait a sec, and then I'll tell you all when you can either raise your hand or type it in chat after we work on it for a bit.
We have a question from Kang. When the question says give an answer, can we directly give the answer?
So you just need like to write down just what the explicit answer is without showing work. It'd be better if you show how you got your answer, because especially like for homework, you can get partial credit on your problems. So if the answer you give is just entirely wrong, then you're not going to get points for that problem. But if you have some work kind of showing how you derived those formulas, then that would help you earn partial credit and such if you didn't quite get it right. So I'd recommend showing your work when it just says, even though it says just give the answer, make sure you show how you got that answer as well.
And someone wants to go over the logic symbols again.
Sure, yeah, so I just wrote them here. So yeah, so remember we've got this kind of upside down V, and that is the and symbol. This kind of V symbol, that's our or. And then this symbol here is our negation, or basically like the opposite of. One way for kind of having trouble to kind of remember some of these is for the and symbol, that I kind of like to remember when I was learning it, is that it looks kind of like an A. So you can kind of remember that symbol's for and then the other one would be for or. And then Brendan, I don't know how to show the workings for these questions. Okay, yeah, so maybe we can just go through one as a practice, and then we'll go through the two. So does anybody have any guesses, either by raising their hand or putting in chat, for what they thought a solution for part A might be? So we had Jake and Xavier. I don't know which one of you raised your hand first, but one of you can go.
I was just going to say not P and parenthesis Q, not C.
Not P parentheses.
Or not P and parenthesis Q, not C. Or Q and C.
Q and C or Q or C?
Q and C.
Q.
Oh no, Q or C. Q or C. Pain.
Q or C. I think you mean Q or R, right?
Just, R. My bad.
Yeah, no, it's a little bit tricky because we've got these, other variables representing truth
Right.
value and.
My bad.
Yeah, it looks like we've got some similar answers in chat. Some say, yeah. So, yeah, this is a good one. But let's go ahead and go through how we kind of come up with this. So we've got here, first we've got A is lying. Well, we don't quite have a variable that represents A is lying, we know that we have P that represents A as truthful. But if we take the negation of A, or the opposite of that sentence, that means that A is lying. So we know that not P is basically the statement A is lying. And then we've got this other part of our statement that B or C is truthful. So we can represent that. This one, B or C is truthful. That's really the same as saying that B is truthful or C is truthful. So we can kind of turn the statement that B or C that's really the same thing as saying Q or R. And then if we want to take the whole statement, A is lying and B or C is truthful, then we've got A, so we've got not P. For A is lying, we need an and. Then B or C is truthful, Q or R. Now the only a little bit tricky part here is to figure out kind of the parentheses. So we kind of have this grouping, and this is just kind of the way that we speak our sentences a little bit differently than how we might write them. We've got A is lying and B or C. So this or kind of groups B or C together. So we want our parentheses to kind of group these two together. So we've got not P and Q or R. And then that would give us the A is lying and B or C is truthful. And then it looks like Brendan had a question if that was true without the brackets. Wouldn't the table be identical for both with and without the brackets? We do need the brackets here, just because if without the brackets, we need to have some sort of notion of kind of like order of operations here. So if we just had not P and Q or R, let me go to another page and I can kind of explain this. So if we had not P and Q or R, we could actually end up with different values depending on if we had parentheses here or if we didn't. Well, can we? Yeah, we could. So as an example, let's consider the case when P is true. Yeah, you could just compare it to the distributive form. Yeah. So yeah, if we let P I can't think of one right off the top, but yeah. These will give different results. The reason is because when we kind of do this order operations, it's like we've kind of grouped these two together. And this doesn't quite work. If they were ORs, it would work. With ORs, we have associativity, but won't quite work here. So yeah, I would just leave those parentheses in. And it also makes it clear just kind of what you mean exactly by the groupings. Yeah, Nicole said if P is true, Q is false, and R is true, I don't think it works. Yeah, I was trying to come up with something like that, and that might not work. But yeah, so let's go ahead. So we got our A done. We had not P and Q or R. So everyone wants to take just a little bit of time on B. So how could we represent? Now we've kind of got a little. Maybe it's a little bit more clear what we're asking for some of you who are asking questions before. how do we do A and B are lying or A and C are truthful? Okay, so it looks like we've got most people look like they're done, and we've got some answers in the chat. Yeah, okay, so this is good. So we've got, for part B, we've got 2 answers here. So one said not P and Q or P and R. And then we've got another one who's saying not P and not Q or P and R. So anyone else have any guesses different than either of these two? Yeah, okay, so we've got 2 who raised their hands. So if Jackson, if you want to go ahead.
Okay, I have not parentheses P or Q and P and R.
Okay. And then I think Jake, you also had your hand raised. You can.
That's what I was gonna say.
That's what you're going to say too. Okay.
Yeah.
So we've got 3 kind of different answers here. Are any of these let's say, and this is really good. I'm glad we got some different ones here, because this problem is a little bit tricky in that the way we kind of just talk in English makes this a little bit hard. We all seem to agree at the end, right, that if we want to represent A and C are truthful, then we can just represent that portion with P and R. So we all kind of seem to agree there. It's just, how do we figure out this, that A and B are lying? And the trick here is that it may be easy to say that, well, if A and B are lying, then that just means that it's not true that A and B are telling the truth. But yeah, okay, so we've got Brendan and some other people. Yeah, so these 2 here are correct. These 2 statements here are equivalent. And yeah, you are right. You can use De Morgan to get between them. But yeah, so if we represent either A and B are lying, that's kind of equivalent to saying that A is lying and B is lying, because we know that they're both lying. And so then here we can see that this would just give us not P and not Q, because it's not A is lying, so that's not P, and B is lying, so that's not Q. But it's not quite the same as this one. So this one doesn't quite say the same thing, not P and Q, and I'll kind of try to go over that. So what not P and Q is saying is, this is saying it's not true. If we convert this to English, it's not true that P that A and B are truthful. And so the part here we have to remember is that we've got these parentheses here. So if it's not true that A and B are truthful, then that just means that one of them is lying. If it's not the case that both of them are truthful, that just means that one of them could be lying, but they don't both have to be. Whereas here, A and B are lying, we mean that both of them are lying. And the other way to see this is that we can use De Morgan's law and note that we can distribute the not if we flip the and to an or, and that's not P or not Q, meaning that either A is lying or B is lying. So this one, the first one we had is not quite correct. Pretty close, but not quite. But these two are the correct statements. And you can either get from both of these just by using De Morgan's law on the first one. You could distribute the not P or Q to get the not P and not Q. So were there any more questions? This one's a little bit tricky on the B, but were there any more questions on this one? No, looks good. Okay. So let me see. Do I have more slide? Okay. So we're going to go C and D. So let me get to a different blank slide. So for C, we had at least 2 people are telling the truth. And then just in the interest of time, I'll just kind of go through this one because I think we're done at 1:45. So I'll just kind of go over how we could get this one done. So we want at least 2 people to be telling the truth. So we could have the case that either A and B are truthful, A and C are truthful, B and C are truthful, or all 3 of them are truthful. So one way we could kind of write this, is if we want at least 2 people to be telling the truth, then we either want the statement P and Q, so both A and B are telling the truth, or P and R, that A and C are telling the truth, or Q and R, that B and C are telling the truth. And this would give us that at least 2 people are telling the truth. So are there any kind of question? And the reason why we don't have to add, you might be wondering, well, why don't we have to add the case? Because for at least 2 people to be telling the truth, we could have all 3 people be telling the truth and it'd be fine. So why don't we have to add that P and Q and R? Why don't we have to add this as one of our answers? And the reason why is that it's kind of already covered here with these ors. As long as 2 people are telling the truth, then one of these values is going to be true. One of those 3 values is going to be true, and we or them together, we'll end up with a true value. So you don't actually need that longer statement there to be added. Are there any questions on that one? No, looks good. Okay, and then let's quickly wrap up with D. So exactly 2 people. Are telling the truth. So similar to the one we just did, but we want to make sure we have the case where A and B and C can't all 3 be telling the truth. So one way we could write this is we could say, well, if we want two people to be telling the truth, we could just say, hey, we want P and Q. So we want A to be truthful, B to be truthful. And if they're both truthful, then we want the case that C is not truthful. And this case gives us A and B are truthful. Or we want the case that P and R, that A and C are truthful and not Q. So here we've got A, C are truthful, not B. Or we want the case that Q and R, so B and C are truthful, but not A. So not B. And then this is saying us that B and C are truthful. So this statement, in each place, we're just checking that only two people are telling the truth. So we just basically converted the statement we had to C, and then we just added the condition in each one of those that either A wasn't being truthful, B wasn't being truthful, or C wasn't being truthful. So any questions on this last problem? Looks like we're good to go, and we're about out of time. So are there any other questions that you had just on anything that we went over? Okay, so Jason had a question on the previous recitation. There was a view problem. Yeah, actually, if you watch, I believe it's lecture 3 or 4, they actually go over that problem again and do it the systematic way. They derive it algebraically. So you'll want to go ahead and take a look at, I can't remember which one it is. It's either lecture 3 or lecture 4, and it'll answer that question that you have. So any others? Awesome. So then we're done for today. So I'll post my scribbles here later today. And if you want to go back and look at kind of what I wrote for the discussions, you can take a look.